All right, you guys, welcome back from break. A little review from chapter 7 in case you guys forgot. Um, so in chapter 7, we did a whole bunch of sample means and we looked at that distribution, and a whole bunch of sample proportions and we looked at that distribution. So if we took a bunch of sample means, think about that bag of pennies where you guys drew out 5 and you took the average, and you drew out 5 and you took the average, and you drew out 5 and you took the average year, all right? So remember that mu of every single x bar, so that's every sample of 5 that we averaged, is equal to the true mean of the population, which was like 2004 or something like that. All right. And then we have sigma x bar. So this is the standard deviation of all the little x bars, is equal to the population standard deviation over the square root of n, which is our sample size. All right. So this right here represents the average or the mean of the sampling distribution. And this is the standard deviation of the sampling distribution for means. For proportions, think when we were drawing out of that bag, we knew 50% of them were red, the poker chips bag. So remember, if we take enough of those little pea hats, you guys drew out 20 chips and you found a proportion that were red, right? If we were to take a whole bunch of 20 chips, put them back in the bag, 20 chips back in the bag, that would be equal to the true proportion of red chips that are in the bag, right? So this mu of p hat is the mean of all the little p hats, all right? And then this is our formula for the standard deviation of the sampling distribution for proportions, which is the square root of p times 1 minus p over n, p being the true proportion of, say, red chips in the bag, and n is your sample size. Okay, so that's a review from chapter 7. So we're going to see if you guys can guess the mystery mean, okay? So what I did is in my calculator, I stored M ahead of time, so you guys don't know what M is. And M is the true mean from some population, okay? We don't know what the population is. It doesn't matter. It's just that the true mean is stored ahead of time, so you guys don't know what it is, all right? The 20 that I'm going to put in the calculator is the true standard deviation, or the population standard deviation. And the 16 is the n, or the sample size. So what this calculator is doing is it's taking 16 numbers from a population that is normally distributed, where it knows the mean is some number, and it knows the standard deviation is 20. All right, and it's going to average those 16 numbers. So this is the mean after we randomly draw 16 numbers from a normal distribution. And let's see what we get on the calculator. So we get 247.3 for our sample. All right, so x bar is 247.3. Again, this is the average of 16 numbers, where the mean is some number we don't know, and the standard deviation is 20 from the population. So you guys, do you think that this sample mean right here is going to be exactly equal to the mystery mean, M, the true mean from the population? No, it's probably not, because what did you guys notice when you drew out those bags of pennies and you averaged those 5 years? They varied from sample to sample, right? Every average of 5 pennies varied from sample to sample. So what I want you guys to do is find a group, all right, a couple other people, and I want you guys to discuss a reasonable interval of values that you think could contain the true mean. All right, so if you know that your sample mean is 247.3, what is a reasonable set of values for the true mean? You guys can pause the video and take about 5 minutes. And I would like every group to share out something that they got and how they got their answer. So if you want to pause again, have every group share what their interval or their range of values is. All right, if you didn't get it, one thing you could do is think about how we could find a standard deviation from a sampling distribution. So remember, we could find a standard deviation from all the little x bars, and we know it's equal to sigma over the square root of n. So sigma from our population in this problem is 20, and our sample size is 16, which means that the standard deviation of our sampling distribution is 5. So the question is, should I add and subtract 5? That'd be 1 standard deviation above and below the mean. And if you guys remember, the empirical rule tells us that about 68% of the data falls within 1 standard deviation of the mean. So is that like pretty good? I don't know, it's okay. What about adding and subtracting 10? Okay, that'd be a lot better because 95% of the data falls within 2 standard deviations of the mean. So that would be a pretty good guess. All right, so we could say, well, maybe the true mean is between 237.3 and 257.3. All right, and yes, we could also do 15, and then we would be 99.7% sure of ourselves from the empirical rule. All right, so what's a confidence interval? A point estimator is a statistic that provides an estimate of a population parameter. All right, so that point estimate is right in the middle of the confidence interval that we're going to find. So the value of that statistic from a sample is called a point estimate. So that 247.3, or whatever we just got, 247.3, is our point estimate. It is going to serve as the center of our confidence interval. All right, and our confidence interval is what we're going to use to guess the truth, okay? And yes, you guys should write this down. All right, a point estimator is a statistic that provides an estimate of the population parameter. So this we usually say with some kind of words. All right, I'm going to use the sample mean or the sample proportion. All right, and then the actual point estimate is the value that we get from our sample mean. All right, so another class did this, you guys, and they got 240.8 for their X bar, okay? So we'll probably use that for the rest of this example, similar to what we got for our 247.3, okay? So let's talk about some of the facts from the sampling distribution. What do we know about the shape? Well, we know the shape is normal because we know that the population is normal. They told us that in the problem, all right? We know that the center of all the little X bars is equal to the true mean. And we know for spread, the standard deviation is equal to the population standard deviation over the square root of n, which we got 5 for. So because of that, you guys, here's our population spread right here, where our standard deviation is 20 and mu's right in the middle. And I take a bunch of samples of size 16, right? So this one gave us 240.8. This average of 16 gave us 246.05, et cetera, et cetera. And we create a sampling distribution, just like we did with the pennies. And notice my sampling distribution goes a little higher here than this one because our spread decreases every time we do this problem because we're taking samples of size 16. It's going to change our standard deviation. Okay, for the following, let's find a point estimator and calculate the value of the point estimate. So for this first one, you guys, we've got AA batteries. There are 50 of them, and this is how long each of those batteries lasted. So they took this sample of 50, and we want to find then the average of the 50. All right, just like we drew out 5 pennies and we found the average. So you would plug all those into your calculator if they ask you to do this on the homework. Yes, it's annoying to plug in 50 numbers. All right, and you would find X bar. All right, so the average is 16.72 hours. Okay, so X bar, 16.72 hours. And this is called the point estimate. All right, so this is going to serve as the center of my confidence interval. And I'm going to guess a range of answers from here, which we'll get to. But for now, they just want the point estimate. Okay, so we just found the average of these 50 batteries. All right, B says, what proportion of U.S. high school students smoke? The The 2011 Youth Risk Behavioral Survey questioned a random sample of this many students in grades 9 through 12, and of those, this many said they had smoked a cigarette at least one day in the past month. So you guys want to think, am I doing means or proportions? So this one was talking about means because it says the word average in here and it says means right here, okay? For this one, we're now talking about proportions. So notice I use X bar to estimate mu, the true mean. I now use P hat to estimate the true proportion of teens who smoke, all right? So we just write a fraction, and we can calculate that. So about 18% from this survey said that they smoke. So P hat is our point estimate. All right, and you got to make sure you get the right notation. X bar for means, P hat for proportions. All right, the quality control inspectors in Part A want to investigate the variability in battery lifetimes by estimating the population variance sigma squared. So again, we don't know the population. We only took 50 batteries, but from those 50 batteries, we do know their standard deviation. Now, I want you guys to be careful here. On the homework, make sure you use S sub x, all right? If you're ever not sure, use S sub x. It is from the sample, okay? So this is the standard deviation from the sample, which is 0.664. So S sub x equals 0.664. However, this is the standard deviation. It says to use the variance, so I need to square both of those. And so my units would be in hours squared. So again, you guys, this is the point estimate, which I am using to then form an interval to guess what the population variance is, because we don't know the true population variance. So a couple ways to write a confidence interval, you guys. So if your X bar is 240.8, you can add and subtract 10 and write it like this. Or you could actually add and subtract 10 and write it like this. Or you could put parentheses and a comma. You'll see it like this a lot in the book, okay? So if they give you this, and then they say, what's the point estimate? How could you find the center of this confidence interval? Yeah, just add them and divide by 2. So you guys, the point estimate of this is the center, which is 240.8. And then they may ask you for the margin of error. So if you notice, what is the margin of error? Well, it's the difference from the center to either endpoint. So in this case, the margin of error is 10. All right, so this interval, you guys, gives a set of plausible values for the true mean. For this one, we're 95% confident because we used 2 standard deviations above and below our X bar. All right, so we wouldn't be surprised if any of the values in this interval actually turn out to contain the true mean. But plausible does not mean the same thing as possible. So any value technically is possible, right? But it's plausible that it's unreasonable that it's actually in that confidence interval. So you guys, there's a trade-off for being more and more confident, right? So we use 90% a lot for our confidence interval, and sometimes we use 95% for our confidence interval. If I want to be 100% confident of something, well then I really lose my reliability. For example, if we look at tomorrow's weather and I'm like, you know what, I am 100% confident that tomorrow's temperature is going to be between 40 degrees below 0 and 200 degrees above 0, right? That loses a lot of precision. It is not very accurate. All right, you guys, definitely write this down. This sentence is never going away. You're going to see it for the rest of the semester, and it is super important. All right, how to interpret a confidence interval. I am blank % confident, So if we were doing the last one, we would be 95% confident that the interval from blank to blank, so for the last one, we had 240.8, just kidding, 230.8 to 250.8, captures the true, and we're either talking about the true mean or the true proportion in context. So last year they told us that the Pfizer vaccine was effective here. We were 95% sure that it was effective, and its efficacy was between 90.3% and 97.6%. If you guys need to pause it, make sure you pause it. This sentence is super important. Okay, so 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, the 95% confidence interval for the population proportion who favor candidate A is between 48% and 54%. Interpret the confidence interval. So we're filling this in. I am 95% confident that the interval from 0.48 to 0.54 captures the true, and you have to say this part in context. So this would be the true proportion of the population who would favor candidate A. Okay, what is the point estimate that was used to create the interval, and what is the margin of error? So if they give you the confidence interval, the point estimate is the center of the confidence interval. So we would add 0.48 and 0.54 and divide by 2. And if we add those and divide by 2, we get 0.51. All right, so our point estimate is a p hat because we're doing proportions, and it's 0.51. Again, it's right in the center of those two. All right, so then what's our margin of error? And by the way, you can use ME. Everybody knows that means margin of error, okay? So the margin of error is how far from the center to either tail. So if you just do 0.54 minus 0.51, it's always a distance, so you don't ever need a negative. We get 0.03 for our margin of error. So based on this poll, a political reporter claims that the majority of registered voters favor candidate A. Use the confidence interval to evaluate this claim. So you guys, can we say that a majority of voters favor candidate A? The answer is no, you guys, because this includes 0.48. So is 0.48 a majority? No. Is 0.49 a majority? Nope. So the only time you could say a majority is if the entire interval is above 50%, right? Then you could say, yep, a majority favor candidate A. But we don't know for sure if the true proportion is 0.48 or 0.49 or 0.54, all right? So as long as the whole interval is above, you could say yes. Otherwise, we need to say no. All right, let's look at some confidence intervals. All right, so notice our two distributions. In gray here, we've got the population distribution, so there's a lot more spread, and then we have our sampling distribution here. And right in the middle is the true mean of the population, so it's also the center of our sampling distribution. So for this one, we are going to do a confidence level of 95% and a sample size of 20. So if I just do one of them, these little dots, there's 20 little dots, all right, that come from the population, and then we average them. So if you're thinking about 20 pennies and averaging the year, the center is right here. So this middle part where the little dot is an X bar, all right? And then we are adding and subtracting a margin of error for our confidence interval, all right? So did that confidence interval capture the true mean? Yes. All right, let's do another one. Did that confidence interval capture the true mean? Yes, it did. All right, let's do a whole bunch of them. So you guys, I just did 31 right here, and 30 of them captured the true mean. So where this green line is where the truth is, right? This guy that's in red missed it. So even though we got a sample right here, it was a little high, our X bar, where we averaged 20 of something, and we found a margin of error, it did not include the true mean, okay? So what does this 95% actually mean? If I keep taking a whole bunch of these, I should get closer and closer to this percent hit of being 95%. All right, so this 95% confidence is a capture rate. So it means that I am most of the time going to capture the true mean in my confidence interval, but 5% of the time I'm not. Okay, if I change this to 90% confident, all right? Same thing, I take a whole bunch of confidence intervals and I find a whole bunch of them, and notice that some of them don't capture the true mean. Notice what happened when I went from 95% to 90% to the length of that bar, you guys. Let's see, we've got our 95. Let's go down to our 90. The bar got a little bit less wide, right? Okay, so this time it only hits 90% of the time, right? I'm going to miss it 10% of the time. And then same thing, let's say we go to even lower. I'm 80% confident now. So what happens here is I'm only going to hit the mark 80% of the time. Oh, it's really off. All right, so this should get closer and closer to 80%, but notice we're missing the mark quite a bit. However, what happened to our confidence interval width? It got a little bit thinner. So we're more accurate here, which is good, but we're not hitting the mark as often. All right, so the most important thing here is, what does confidence level mean? Okay, so confidence level is the overall capture rate. If you use this method many, many times, this is the sentence you need to write down word for word, all right? And you need to memorize and know this sentence. So if the random sampling or random assignment were repeated many times, about blank percent of the resulting confidence intervals would contain the true mean or proportion in context. So feel free to pause if you guys need more time to write down that definition. So interpreting a confidence interval and a confidence level are two different things. You got to have both sentences and you got to know the difference, all right? So think of confidence level as a capture rate of many, many confidence intervals. So the confidence level, you guys, does not tell us the chance that a single particular confidence interval captures the true population parameter. So the one that we did, the 230.8 to the 250.8, I actually don't know for sure if that contains the true mean, all right? I know that it could or it couldn't, and if I do a whole bunch of them using that same method, then 95% of them will capture the true mean. All right, so if they ask you, by the way, what is the chance this particular confidence interval captured the true mean? We don't know. It's either 100% it has it in there, or a 0% it doesn't have it in there. All right. Okay. How much does the fat content of brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population standard deviation is 2.84 to 7.55. Interpret the confidence interval. All right, so for confidence interval, you guys, that's not this one. This one's confidence level. So for confidence interval, we got to go back to this one right here. Nope, that's level. Okay, this one right here. So I am blank percent confident that the interval from blank to blank captures the true whatever we're talking about, okay? So for this one, we would say I am 95% confident that the interval from 2.84 to 7.55 captures, and in this case, we're talking about the true population standard deviation. All right, interpret the confidence level. So now we're doing this guy right here. So if the random sampling were repeated many times, about 95% of the resulting confidence intervals would contain the true, in this case, standard deviation is what they're talking about for this one. All right. True or false? The interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation. So you guys, this question, they ask this a lot. It's trying to get you to understand what this 95% means. So this one single interval, it's not a 95% chance. It either captured it or it didn't, all right? The 95 comes from repeating a whole bunch of them. So this is false, all right? Once it's calculated, it either contains the true standard deviation or it doesn't. All right, you guys, go ahead and work on the worksheet, and then we'll go over it. So if you guys want to pause the video here and take a few minutes to do 8.1a, that would be great. All right, so for this first one, hopefully you put something like this for your sentence. And for B, hopefully you put something like this for your sentence. All right, for this last one, it's kind of tricky. It's like, what are they looking for? But basically, a lot of times they're going to start asking, so do we have evidence that maybe the bottles are not really, do they really don't have 20 ounces in them, as the company claims? But if you look at this right here, the center, if you were to add them and divide by 2, you could find your sample mean, your X bar. And also because this 20 is in that interval, I feel pretty confident that this is a trustworthy amount, all right? So we do not have evidence that the company is lying to us, all right? The average contents for the sample was 19.92. That I got from averaging those two numbers, so finding the middle of the confidence interval. And since 20 is in that interval, we're good to go, all right? The company's claim is they're probably being truthful.